Weighing less than a single ounce and measuring just 2 inches long, a sea turtle hatchling begins its life buried under the sand. To break out of its shell, it uses a temporary, sharp bump on its snout called a caruncle, an egg tooth that falls off shortly after hatching. Once free from the shell, these tiny reptiles enter what marine biologists call the frenzy period. For the next 24 to 36 hours, they rely on pure instinct to sprint across the beach and swim continuously, desperately trying to scramble past predatory birds, crabs, and fish. Natural predators are a severe threat, but human development complicates the route. On heavily built coastlines, bright artificial lights from hotels and streets confuse the hatchlings, drawing them away from the moonlit ocean. Furthermore, coastal erosion and concrete seawalls steadily wipe out the sandy real estate they need to nest in the first place. If the hatchling successfully makes it to the surf, it is immediately engulfed by the crushing weight of the open ocean. A 2-inch animal is now at the mercy of massive global currents. Surviving that frantic dash across the sand is only the first millimeter of a journey that will span tens of thousands of miles. It marks the beginning of a mysterious decade at sea, known to scientists simply as the lost years. To survive those lost years, many sea turtle hatchlings ride the currents to the open ocean. Here, they find floating islands of golden brown algae called sargassum, which provide a rare canopy of shelter and a reliable source of food far from the coast. Within this floating nursery, juvenile turtles adopt a sit-and-wait strategy. Their dark brown and black shells blend effectively with the tangled algae, allowing them to hide from large fish, while effortlessly ambushing tiny shrimp and crabs drifting by. The same currents that gather the seaweed now concentrate massive amounts of buoyant plastic debris. This synthetic waste occupies the exact same ecological space as the hatchlings, turning their sanctuary into a collection point for lethal pollution and massive, unnatural algae blooms that can physically trap the babies. Even in a healthy algae mat, the turtles cannot afford to passively float forever. The sargassum is constantly drifting toward the edges of warwash currents. If a young turtle gets swept outside this thermal boundary, the freezing waters prove lethal. Navigating thousands of miles across the open ocean requires a mechanism for finding direction in a world without landmarks. Above the surface, a turtle's vision is nearsighted, and below there are no maps to help a 2-inch hatchling identify its position in the featureless blue. This diagram illustrates their solution. Hatchlings possess an internal magnetic compass. They can physically feel both the angle and the intensity of the Earth's magnetic field lines, reading these invisible forces like a grid. By reading that grid, they lock onto warm circular systems like the North Atlantic Gyre. When the turtle detects the specific magnetic signature marking the outer edge of this safe zone, it instinctively turns and swims back toward the center, correcting its course. No older turtle teaches them this route. The hatchlings are born with a completely pre-programmed magnetic map of an ocean they have never seen. This biological GPS is the ultimate key to their survival, allowing a 2-inch animal to master global geography until it is mature enough to return to the coast. After about a decade in the open sea, the lost years come to an end. Now roughly the size of a dinner plate, the juvenile turtles migrate away from the deep ocean and settle into vibrant, shallow coastal waters. Here, they take on a specific ecological job, functioning as high-efficiency marine lawnmowers. Species like the green sea turtle spend their days continuously grazing on vast underwater meadows of coastal seagrass. This constant grazing keeps the seagrass closely trimmed. Without the turtles, the grass blades would grow too long, accumulating sediment, blocking sunlight, and eventually suffocating the neighboring coral reefs. By keeping the seagrass in check, the turtles ensure the corals receive the sunlight necessary for photosynthesis. The structural health of the reef is directly tied to the daily feeding habits of the sea turtle. Decades of foraging along these coasts trigger a massive physical transformation. Between 10 and 50 years after hatching, that 2-inch baby has grown into a heavily armored 300-pound adult. Reaching sexual maturity brings a deeply ingrained urge to mate. Relying on that same magnetic GPS, the adult turtle will swim thousands of miles across the ocean to return to the exact coastal region where it hatched. For the females, this return requires a grueling physical toll. Built for the buoyancy of the ocean, she must drag her massive body out of the water and up the beach, using her heavy flippers to painstakingly carve out an egg chamber in the sand. By safely depositing her eggs in the very sand where her own life began, she closes a perfect biological loop, proving the reliability of a magnetic memory that has guided her across a lifetime. Today, human activity disrupts every stage of that loop. Beyond the obstacles on the beach and the plastics in the deep ocean, adults face the constant lethal threat of becoming entangled in discarded commercial fishing gear. A single sea turtle's life cycle connects deep oceanic currents, floating algae mats, and shallow coastal reefs. Because they bridge so many distinct environments, environmental degradation in any one of those zones ripples through the turtle's entire population. Targeted human intervention can help repair these breaks in the cycle. Enforcing federal fishing regulations to reduce net entanglements and implementing strict local guidelines for sustainable beach development give the turtles the safe passage they require. Protecting the 10,000-mile journey of the sea turtle ensures they can continue to trim the seagrass and support the reefs. Securing their future is a direct investment in the interconnected health of our global oceans.